हेलो स्टूडेंट्स, वेलकम टू दी बोरिंग स्कूल, जहां हम केमिस्ट्री को याद नहीं करते बल्कि समझते हैं। एंड टुडेज टॉपिक ऑफ द डे इज thermochemistry. So before diving it into the topic, I'm assuming that you are aware about the first law of thermodynamics because I am going to use first law of thermodynamics. This thermochemistry is basically the application of first law of energy can neither be created nor be destroyed. It can only change from one form to another. So I hope you are clear with the first law. And before wasting and without wasting any time, let's directly dive into the topic, which is thermochemistry. So let's unlock the mystery behind the chemistry of thermochemistry. So thermochemistry basically is the branch of thermodynamics which deals with the exchange of energy in a reaction. It's a branch of thermodynamics in which we deal with exchange of energy in a reaction. So let's write that. First point, it deals with the exchange of energy in the reaction. It deals with the exchange of energy in the reaction. First point. Let's take an example. A gas plus B gas giving us capital C gas plus D capital D gas. This is a chemical equation. This is a chemical equation in which we have written the reactants which are capital A, capital B, the products which are capital C and capital D, and small a, small b, small c and small d, they are representing the stoichiometric coefficients. Now, we have to study about the exchange of energy. So we can write the heat which is exchanged in a reaction. So let's say Q joule of heat is produced in the reaction. So this type of reaction in which we specify the physical state of the reactants, physical state of the product, and the heat which is exchanged, it is known as thermochemical equation. So let's write the next point, that is thermochemical equation. Thermochemical equation. So how do we define thermochemical equation? So before that, how do we define chemical equation? So chemical equation is nothing but a symbolic representation of a chemical reaction. Symbolic representation of chemical reaction means we have to mention the reactants and products in terms of their symbols. So a thermochemical equation is defined as it is the representation of a chemical reaction. It is the representation of the chemical reaction in which the physical state, allotropic form of the reactant and product, allotropic form of the reactant and product, and heat exchanged in the reaction, heat exchanged in the reaction, heat exchanged in the reaction is specified. So those reactions in which we mention the physical state of the reactant product. If any allotropic form is there, then it is specified, as well as we are mentioning how much heat is exchanged in the reaction. So those type of chemical equation are known as thermochemical equation. Okay. Now moving further. Based on the amount of heat exchanged, based on the heat exchanged, based on the heat exchanged, a reaction can be of three types. Based on heat exchanged, a reaction can be of three types. What are those types of reaction? First one is exothermic reaction. First one is exothermic reaction are those reactions in which heat is released. Those reactions in which heat is released. Those reactions in which heat is released are known as exothermic reaction. We can take an example. Example can be combustion reactions. All combustion reactions are exothermic reaction. Then combination reactions. Combination reactions can also be exothermic reactions. Okay. Moving to the second type, that is endothermic reaction. Second type is endothermic reaction. So endothermic reactions are those reactions in which heat is required. Those reactions in which heat is required, they are known as endothermic reaction. For example, decomposition reaction. For example, decomposition reaction. So in case of decomposition reaction, energy is required to break the bond. And the third one is thermoneutral reactions. Third one is thermoneutral reaction. So thermoneutral reaction are those reactions in which there is no exchange of heat. Those reactions in which there is no exchange of heat. Those reactions in which there is no exchange of heat are known as thermoneutral reactions. For example, AgClO2 solid giving Ag solid plus half of Cl2 gas plus O2 gas. This reaction is thermoneutral reaction because in this case there is no exchange of energy, means there is neither loss of energy nor gain of energy. So we have three types of reactions based on the energy which is exchanged. Now let's take one more example again. Let's take one more example. Suppose we are having, let's take the previous example only, that A gas plus B gas is giving us C gas plus D gas. This is unbalanced reaction. So we have to write some stoichiometric coefficients. So A, B, C and D. Small a, small b, small c and small d are stoichiometric coefficients, and some Q joule of heat is released. Now in this case heat is released, it means it is an exothermic reaction. Heat is released, that is why it is an exothermic reaction. I hope this much is clear. Now the heat which is released in this reaction, the heat which is released in this reaction, this heat is known as heat of reaction. With respect to this, we'll write heat of reaction. So what is heat of reaction? So heat of reaction is the heat exchanged in a particular reaction. Heat of reaction is, it is the heat exchanged. It is the heat exchanged in a reaction. This Q joule which I have written, that is known as what? Heat of reaction. Let's say if I'm having a reaction like M gas plus N gas plus Q joule is giving us O gas plus P gas. Let's write stoichiometric coefficients M, N, O and P. So this is a balanced chemical equation, and this Q joule of heat which is written over here, it is getting added to the reactant, which means this reaction is what? It is an example of endothermic reaction. It is an example of endothermic reaction, and this Q joule will be known as what? This will be known as heat of this reaction. So that's why we write it as heat of reaction. Now, this reaction which I have written over here, or any particular reaction, can take place either at constant pressure condition, it can take place at constant pressure condition, or it can take place at constant volume condition. The reaction can take place at constant pressure condition, or it can take place at constant volume condition. Now, in case of constant pressure, the heat which is exchanged, that is written as QP, and that will be equal to delta H of the reaction. What is delta H? That is change in enthalpy. And same way, if it is done at constant volume, then that heat will be written as QV, and that QV will be equal to delta U of the reaction. So at constant pressure means it is taking place in an open container. Constant volume means it is taking place in a closed container. Constant pressure means open container. Constant volume means closed container. Now in laboratory, most of the reactions which we perform, that generally is performed in a test tube. And test tube is an example of constant pressure condition. That is why the heat which is generally mentioned, it is always written delta H, not delta U. Is this point fine? Why we write delta H always? Because most of the time the reaction is performed in a test tube, which is an example of constant pressure condition. So this much is fine. Now, this delta H or delta U can be positive, can be negative. It is positive if the reaction is endothermic. It is positive if the reaction is endothermic, and this will be negative. This will be negative. Delta H or delta U will be negative if the reaction is exothermic reaction. For example, if I am saying that delta H of a reaction is minus 50 kilojoule per mole, it means 50 kilojoule of energy is released. I have said delta H is minus 50 kilojoule per mole. Minus 50 means it is exothermic, means that much amount of heat is released. So we can say 50 kilojoule of energy is released in the reaction. Same way, if I am saying delta H is plus 50 kilojoule per mole, that means 50 kilojoule of energy is added to the reactant side, or is required for the reaction to occur. Is this point clear? Okay. So I hope you are clear with the concept of exothermic reaction, endothermic reaction, when a reaction is exothermic, when a reaction is endothermic, what is delta H of a reaction and what is delta U of a reaction. Next, we'll discuss factors affecting the heat of reaction. Factors affecting the heat of reaction. Factors affecting the heat of reaction. First factor is physical state. First factor is physical state. Now, if physical state of the reactant or physical state of the product is changed, then the heat which is exchanged, that will also be different. For example, if I write a reaction as H2 gas plus half O2 gas giving us H2O gas, and second reaction I'm writing H2 gas plus half of O2 gas giving us H2O liquid. Now delta H of this reaction, let's say, is X1. Delta H of this reaction is X2. So you should be clear with this point that X1 will not be equal to X2. X1 will not be equal to X2. When the physical state of the reactant and product is changed, then what will happen? The heat of the reaction, that will also change. So physical state is first factor which affect the heat of reaction. Second factor is allotropic form. Second factor is allotropic form. If allotropic form of the reactant is changed, then also heat of reaction will change. For example, if I'm having carbon graphite solid plus O2 gas, let's say it is giving us CO2 gas, and delta H of this reaction is X1. And we have carbon diamond, this is also in solid state, plus O2 gas. This also is giving us CO2 gas. Delta H for this reaction is X2. Now again you should know this point that X1 will not be equal to X2. Both of them are combustion of carbon itself, but the allotropic form of carbon is different. That is why the heat which is exchanged in the reaction, that will also be different. Okay. Third factor is temperature. Third factor is temperature. So both delta H and delta U, both delta H and delta U depends on temperature. Both delta H and delta U depends on temperature. We can write Kirchhoff's equation. This is given by Kirchhoff's equation. Given by Kirchhoff's equation, which says that delta H2 minus delta H1 upon T2 minus T1 is equal to delta Cp. Delta H2 is what? It is change in enthalpy at temperature T2. Delta H1 is change in enthalpy at temperature T1. And delta Cp is change in heat capacity at constant, molar heat capacity at constant pressure. Same way, we can write delta U2 minus delta U1 upon T2 minus T1 is equal to delta Cp. Same way, delta U2 is change in internal energy at temperature T2. Delta U1 is change in internal energy at temperature T1. And delta Cv is change in heat capacity at constant volume condition, or we can say change in molar heat capacity at constant volume condition. So this is third factor. Moving to the next, reaction condition. Reaction condition. Reaction condition means whether the reaction is taking place at constant pressure condition or it is taking place at constant volume condition. So we know at constant pressure condition, the heat which is exchanged, that is equal to delta H, and at constant volume condition, the heat which is exchanged, that is represented as delta U. Now, how are they related to each other? How delta H and delta U are related to each other for any particular chemical reaction? So we can write the relation is delta H is equal to delta U plus delta Ng RT. Let's say if I'm having a reaction like AA gas plus B gas giving us CC gas plus D times D gas. So for this reaction, delta Ng, if I have to write, that will be equal to C plus D minus of A plus B. It means it is sum of stoichiometric coefficients of gaseous products minus sum of stoichiometric coefficients of gaseous reactants. So point is important, it should be gaseous products and gaseous reactant. If any solid is there or liquid is there, then it is not considered. Only we have to consider the gaseous reactants and the gaseous products. Now let's take an example of this. Let's say the reaction is N2 gas plus 3H2 gas giving us 2NH3 gas. So what will be delta Ng for this? So it will be 2, which is for product, minus for reactant will be 1 plus 3. So delta Ng will be minus 2. Let's take one more reaction. PCl5 gas giving us PCl3 gas plus Cl2 gas. In this case, delta Ng, if I have to write, that will be 1 plus 1, that is for product, minus 1, which is for reactant. So in this case, it is 1. Let's take one more example. 2SO2 gas plus O2 gas is giving us 2SO3 gas. Delta Ng for this will be equal to 2 for product minus 2 plus 1 for reactant. So 2 minus 3 will be minus 1. Let's take one more example. H2 gas plus Cl2 gas giving us 2 HCl gas. So delta Ng in this case, it will be 2 minus 1 plus 1, which is equal to 0. So we can see that delta Ng can be positive number, it can be negative number, or it can be 0 also. And based on delta Ng, we can compare that between delta H and delta U, which will be more. So we can see if delta Ng is equal to 0, then delta H is equal to delta U. If delta Ng is more than 0, then delta H is more than delta U. And if delta Ng is less than 0, then we can write delta H will be less than delta U. Like we have taken examples over here. So for these reactions, we can write, like in the first one, delta Ng is less than 0, which means delta H is less than delta U. For second reaction, delta Ng is more than 0. So I can write delta H is more than delta U. For third reaction, delta Ng is less than 0. So we'll write delta H is less than delta U. For fourth reaction, it is equal to 0. So we'll write delta H is equal to delta U. So one question you can expect of this type, that they will ask for which of the following reaction delta H is more than delta U, or for which of the following reaction delta H is less than delta U, or for which of the following reaction delta H is equal to delta 2. So this is the point. So this was fourth factor. Fifth factor is stoichiometric coefficients. Fifth is stoichiometric coefficients. For example, fifth is stoichiometric coefficients. For example, we have a reaction 2A gas plus B gas giving us 2C gas. And delta H for this, let's say, it is written as X kilojoule per mole. Let's say delta H given is X kilojoule per mole. Now, if this reaction is multiplied by any number, let's say N. If reaction is multiplied by a number N, then delta H will also be multiplied by N. Delta H will also be multiplied by N. For example, same if I write, we'll get 2N A gas plus N times B gas is giving us 2N times C gas. So delta H for this reaction will be N times X kilojoule per mole. N times X kilojoule per mole. So if a reaction is multiplied by any number, delta H will also be multiplied. If a reaction is divided by any number, then delta H will also be divided by that number. Means whatever operation you are doing on the chemical equation, same application you have to do on the heat of that particular reaction. Whatever operation you are doing on the chemical equation, same operation you have to do on the heat of that particular reaction. Another point is, over here they have written kilojoule per mole. So what is this per mole? Whether it is per mole of A or per mole of B or per mole of C, or it is anything else. So this basically is per mole of the reaction. It is defined as per mole of the reaction. It is defined as per mole of the reaction. Now, when I'm saying per mole of the reaction, it means, this means for 2 moles of A, 1 mole of B and 2 moles of C. When I'm saying per mole of reaction, means we will have 2 mole of A, 1 mole of B and 2 moles of C. Is this point clear? So these are the factors which affect the heat of reaction. So I hope you have understood the basics of thermochemistry, what is heat of reaction and what are the factors which affect the heat of reaction. So let's keep it till here in the first part of this lecture. In the coming lecture, we'll be discussing about the Hess law. Next, we'll discuss about the different types of heat of reaction, in which we will be covering about the heat of formation, heat of combustion, heat of neutralization, heat of solution, then heat of ionization, heat of electron gain enthalpy. So there will be multiple heat of the reactions which we are going to cover in the coming videos. I hope you have liked this video. If there is any doubt, then you can comment down and I will be very happy to answer. Your doubts. So I hope all of you will complete this. You'll make a proper note of all the points which we have discussed and you'll try some questions based on the points which we have discussed today. Hoping to see you in next video.